Alright everyone, so today we are going to discuss this chapter. There is something special in this that we are going to verify, surface area and volume. So we are going to discuss the relationship between the volumes of few solids that we are having with us. So this is a cylinder as you all know, then this is a sphere and this is a cone. And here we are having a special situation with these three, that the radius of the cylinder and radius of the cone, they are same. Can you see that?
Yes,
They are same. Alright? And then if I invert this cone and put it inside like this, can we see that the heights are also equal for the cylinder and of the cone? Right? Now I have the sphere also. Just ignore the thickness. If I try to put it inside, can you see the radius is almost same?
Yes, ma'am.
There is a small difference, but we can ignore that for now. And if I drop it in this completely like this, so what we are observing, this sphere is completely or exactly enclosing into the cylinder. That means what? The diameter of the sphere and height of the cylinder are same. Alright, so we have this situation when the radius of all these three, the radii are same and the diameter of sphere is equal to height of the cylinder and that of the cone. So now initially I am going to use these two. Alright, so I have this cone with me. I am filling up this cone up to the brim with this liquid. You can use any other thing for that. You can use sand, you can use salt, you can use some grains also. But while using the grains, try to use those grains only which are very small in size, like bajra or dalia. Alright, क्योंकि अगर आप बड़े दाने लोगे, चना, राजमा ऐसी चीजें, so there will be a lot of empty space in between too. Alright, so this is filled with the liquid up to the brim. Now it is not having any sharp edge over there. So just for my comfort purpose, I am shifting this liquid into this prism. Alright. So this liquid that is there in the prism right now is representing volume of a cone. Alright. Because I have shifted this liquid from the cone. So now see, this is the sphere that I have with me and there is a hole in this. Can you see the hole, everyone?
Yes, ma'am.
So what I am going to do, I am going to transfer this liquid from this hole into the sphere. Alright? So you have to be very careful while doing this because the hole is small, so there is a lot of spilling possible. So I am shifting this liquid into the sphere. And when the entire liquid is being poured into this, we'll observe something. Here at this moment we can see that half of the sphere is filled.
Yes, ma'am.
Can you see this?
Yes, ma'am.
Is it visible to everyone?
Yes, ma'am.
Half of the sphere is filled. And what is half of a sphere?
Hemisphere.
Hemisphere. So can we say that if a cone and a hemisphere are having same radius, and the cone is having height is equal to twice of the radius, that is diameter, in that case volume of a hemisphere and volume of a cone will be same. So in this particular situation, can we conclude that if I offer you a glass of juice which is in shape of a cone and with same condition dimensions, I serve you the same juice in a hemisphere, the quantity will be same?
Yes, ma'am.
So you can choose any of the two. Alright. So now what I am going to do, I want your help, Nalin, please hold it. You can sit. I am filling up the cone again for the second time now. This is for the second time. Just keep counting the number of times I am filling up the cone. So this is second time. It is being filled up to the brim. Again, just for my comfort purpose, I am shifting this liquid into the prism. So now this liquid is representing volume of a cone. Give it to me. Again shifting this into this. So I can see that this sphere is filled completely and there is some leakage because of the material of the product. But we can see that the sphere is filled completely now.
Yes, ma'am.
So can we conclude that two cones are completely filling up a sphere? That means volume of two cones is equals to volume of a sphere under that condition that we are studying. Alright. So just for saving that spill, I am transferring this liquid into this box. Also, do we have a flat surface in sphere?
No, ma'am.
That is why I would not be able to put the ball over there on table. Otherwise it will drop down and entire liquid will spill. That is the reason why I am shifting it into a cube which is having a flat surface. Alright. So I just want to take a pause over there. So I am having a condition when I have a cone whose base radius is r and height is h, and I have a sphere such that the radius of the sphere is also r, the same radius r, and here the diameter is same as the height of the cone. So we have this situation when they are on the same flat surface and they are sharing the same height. So can I say that height is equals to diameter?
Yes, ma'am.
Alright. And can we replace this diameter with twice of radius?
Yes, ma'am.
Is it fine?
Yes, ma'am.
And we are observing that two such cones, when poured together into a sphere, they are filling it up completely. So is this relation true?
Yes, ma'am.
That means twice the volume of cone will be same as volume of sphere. Is it true?
Yes, ma'am.
Shall we check it?
Yes, ma'am.
Shall we verify?
Yes, ma'am.
So let us start with left hand side. So that is 2. What is volume of cone? We know the formula. 1 by 3 pi r square h. That is r. So that is equals to what? 2 by 3 pi r square h.
Yes, ma'am.
Can I replace this h with twice of r?
Yes,
Yes,
ma'am.
ma'am.
Because this is the given condition. So that is 2 by 3 pi r square twice of r.
Yes, ma'am.
Is it clear to everyone?
Yes, ma'am.
So this will be equal to 2 by 3. 2 into 2 will become 4. So this is 4 by 3 pi r square into r is r cube. And what is this? This is the volume of
Fair.
sphere. So is this relation verified?
Yes,
Yes,
ma'am.
ma'am.
So here we are observing that volume of a cone is equals to volume of a hemisphere of same radius, such that the volume of cone should be the double of the radius. And volume of two cones is equals to volume of sphere under that condition. Is it clear to everyone? Now, let's come back to this thing now. See, in front of you only, I poured the entire liquid of sphere into this. That means whatever liquid is here in this right now, it is representing what? Volume of a sphere. So what I am doing in front of you, I am shifting this volume of sphere into the cylinder. So roughly we can see that this cylinder is almost filled 2/3 times. 2/3 of the portion of the cylinder is
Yes,
filled.
ma'am.
Alright, keeping it here and filling up this cone again. Now this is the third time I am filling up the cone. So for the third time I am filling up the cone up to the brim. And now I am transferring this entire liquid into the cylinder. Like this. So can we see that the cylinder is almost filled?
Yes, ma'am.
Some portion we can ignore because of the thickness of the material of the sphere. Alright. So can we say that a cone when filled thrice will complete a cylinder?
Yes, ma'am.
Or a cone and a sphere of the same dimension will fill up a cylinder. Alright? So again I am shifting it over there in this to keep it comfortably on the table. So suppose now I have three sort of glasses for you. One is a spherical one, maybe open from the top, a bit portion is open. One is conical and the third one is the cylindrical one. And I fill them with juice or ice cream or anything that you like and serve it to you. Which one will you choose? Cylinder, because this will have the maximum volume. Alright? And which one will have the minimum? Cone will have the minimum volume. And cylinder will be the maximum. And sphere will be exactly between the two. Alright?
Yes, ma'am.
So here again